Welcome to the Explainer. Today, I want to show you a brilliant method for solving quadratic equations that you probably didn't learn in school. And trust me, it's a real game changer.
So, if you've ever had to battle a quadratic equation, you know the drill, right? You either reach for the quadratic formula, which is just a whole lot to memorize, or you try factoring, which, let's be honest, can feel like a lot of trial and error. They work, sure, but they're not always the smoothest ride.
But what if I told you there's a better way? A way that swaps out all that memorization and guesswork for just pure logic. We're about to explore a technique that is so elegant and it works for any quadratic equation you can imagine. Now, this whole method, the entire thing, is built on one simple and really beautiful idea: the symmetry of a parabola. And if you get this one thing, everything else just clicks into place. Just picture that classic U shape of a quadratic graph. Well, its solutions, what we call the roots, they are always perfectly balanced on either side of a central line. They're like mirror images, always the exact same distance from the center. And here's the really cool part. We can find this central point, this midpoint, without even knowing what the roots are. This little formula right here, minus b divided by 2a, lets us find the average of the roots just from the equation itself. This is the key that unlocks the whole puzzle. So think about it for a second. If we know the very center, then our two roots have to be that center point minus some distance, and that same center point plus that same distance. We'll just call that unknown distance u. So really, our job is just to figure out what u is.
Okay, so how do we actually turn this cool idea about symmetry into a tool we can use? Well, it boils down to a super simple four-step process that works every single time.
And here it is, the whole method laid out. First, you find the midpoint with our formula. Second, you write out the roots as midpoint minus u and midpoint plus u. Third, and this is crucial, we use another fact, that the product of the roots is always c divided by a. And finally, you just solve that simple equation for u. Let's actually do one.
All right, let's get our hands dirty. We're going to try this with a classic example, and I'll walk you through it step by step, just like we're working it out together on a blackboard.
Okay, here's our equation. X squared minus 6x plus 8 equals 0. First things first, let's just identify our pieces. Here, a is 1, b is negative 6, and c is 8. Simple enough?
Now step 1, find the midpoint. We just use the formula minus b over 2a. So we plug in our numbers, that's the negative of negative 6, divided by 2 times 1, which gives us a nice clean midpoint of 3.
Okay, on to step 2. Since we know our middle point is 3, we can now say for sure that our two roots must look like this: 3 minus some number u and 3 plus that same number u. Perfectly symmetrical. And for step 3, this is where the magic happens. We know from algebra that when you multiply the two roots together, you always get c divided by a. For our equation, that's 8 divided by 1, which is just 8. So we can set up this simple equation. 3 minus u times 3 plus u has to equal 8. Now we just solve for u. And if you remember the difference of two squares, when you multiply 3 minus u and 3 plus u, it simplifies really nicely to 9 minus u squared. So our equation is 9 minus u squared equals 8. A little bit of quick rearranging, and we see that u squared is 1, which of course means u is just 1. And now for the final payoff. We just plug that value for u back in. So 3 minus 1 is 2, and 3 plus 1 is 4. And that's it. We solved it. The roots are 2 and 4. See how fast that was? No guessing involved at all. Okay. I know what you might be thinking. That was a simple one. It had nice, neat whole numbers. What about the trickier equations? You know, the ones with ugly, irrational roots? Does this logic still work? Let's try this one. X squared minus 12x plus 7 equals 0. The numbers look a little tougher, but watch this. The process is identical. We follow the same steps. The midpoint, minus b over 2a, is 6. So the roots are 6 minus u and 6 plus u. Their product has to equal c, which is 7. That gives us 36 minus u squared equals 7. And when we solve for u, we find u squared is 29, so u is the square root of 29. See? Even with messy numbers, the logic is totally clean. So there are our roots. 6 minus the square root of 29 and 6 plus the square root of 29. The method handled it perfectly, giving us the exact answer without having to pull out that long, complicated quadratic formula. It's all just simple step-by-step logic.
So let's step back for a second. Why does this matter? What really makes this method so powerful compared to the ones we're used to?
Well, there are a few huge advantages. First, it just completely gets rid of the guesswork you have with factoring. Second, it gives you a much deeper, more intuitive feel for why the solutions are what they are. It connects the numbers in the equation to the actual shape of the graph. And third, it's a universal key. It works for any quadratic equation, no matter how complicated the answers get.
This quote really sums it up perfectly. It changes the whole problem. You're not just a machine plugging numbers into a formula you memorized. You're actually a detective, using logic and symmetry to figure out the solution.
So, I'll leave you with a little challenge. Go ahead and pause here and try this method on the equation you see on your screen. You might just be surprised how quickly you can find the answer. It's a great reminder that sometimes the most beautiful solution has been there all along, hiding in plain sight.